Hello and welcome to part 2 of this tutorial series where we'll build a full-text search on entities. So far we created a Quarkus application with a Postgres database, and in this part we're going to add Debezium and Apache Pulsar into the mix. So therefore I will just change the configuration of Postgres a bit, and the important part here is the write ahead log level, which has to be set to logical. Otherwise, there's nothing that Debezium can listen to. And the second part is to add Pulsar, and this is just the default Docker setup. Just notice that I'm using here port 8080, which is the default of Pulsar, and also the default of a Quarkus application. And therefore, I have to change one of these ports, and I will just change the port of my application here, because it's pretty easy, and I will just use 8081. And last but not least, for the setup, I will add two new dependencies. One is Pulsar admin client, and one is the actual Pulsar client. Make sure that you use the correct versions, otherwise there might be some problems. Just reload the Maven dependencies and we're good with the setup. So I will use a new package here called search app. You could also extract that into an own microservice if you want, but here it's easier to showcase when I just use one application and put the different applications into different packages. So the first thing where we will use the Pulsar admin dependency is to configure Debezium for us. So I will create a Debezium source config, and therefore I will use just some constants that I will use throughout the whole code. This is basically defaults from Pulsar and the version. And what I want to have here is a method that runs on every start of the application, and in case that the source connector for Debezium is not created already, then it should create it. If it was created before, it should do nothing. So therefore we're going to use the Pulsar admin object, which I will just create here. And again, I prepared that part. It's pretty straightforward. I will do one thing here that you should not do in production code. I will just add exceptions to the method signature. And I don't know why, but these exceptions get swallowed by Quarkus. And so if an error would happen in this setup method, which can happen fairly easy when you do some configuration mistake, then you would have no idea what's went wrong, but your application will not start up properly. So yeah, you've been warned. And next part is we're gonna build the actual Debezium source with the help of our admin object. And therefore we need to configure the actual source. And how we're gonna do this exactly, I will show you in a second. But first I want to flesh out the rough stuff, the overall concept, if you like. So we will send this configuration to the Pulsar cluster, and we will tell it to download the actual nar file, which is a special type of jar, including all its dependencies, and then run this code. Again, I add exceptions to the signature and so on and so on. And as I said in the beginning, we want to make sure that this code does the setup of our Debezium only once, because if you try to repeat it with the same name, you run into an error because you cannot create the same source with the same name for multiple times, obviously. So I will add a little snippet here, just to make sure that we only create it once. So we're gonna list all the sources that we have for this tenant, for this namespace, and we check if it contains this source name, and if it does, then it should do nothing. If we would not do that, we would run into an exception. So the last part missing here is the actual source configuration, and this consists of two parts. One is the actual source configuration, so this is basically a concept from Pulsar, and as you can see, here's nothing special. We just put the tenant name, the namespace, give it a name. We have to define some topic name, but this one we will not use. It's just internal topic for Debezium, so name it whatever you like. We provide where it should actually put the download that we initiated over here. So it will put it here inside of our Docker container. And the important part, or the most interesting part, is the actual Debezium configuration, which we have also to provide here. And again, I already prepared that one because it's quite cumbersome. And let's see what we have here. We have a database server name that can be basically whatever you like. So we'll just call it foobar here. We have to define the schema name, which by default is public in Postgres. And we have to provide a list of tables that we want to listen for the changes. So this one is book in this case, so I want to listen for changes on the book table. And what this will do, given this configuration, is that Debezium will create a topic for us, which has this name, persistent public default foobar public book. And you can see in the line below how this one is created. So it's the tenant name, it's the namespace name, database server, database schema, and the table. So this, of course, depends on the configuration that we just did. All the rest you will find very well explained in the documentation. It's just how to connect to the database and so on and so on. Just make sure that you use the correct terms depending on the version of Pulsar you use, because in 2.9 they changed, or they changed to the newest version of Debezium at that time, and there some of the configuration keys are named different to older versions. All right, but let's use this topic to actually see what this, or to listen to the changes on the database. So therefore I'm going to create a new class. This time we're going to use Pulsar client dependencies. So I go into the Pulsar client package, and I'm actually going to create here a book change listener. And I will use the topic name that we just saw, public default foobar public book. And here we will use a consumer. Make sure that you import the Apache Pulsar consumer and not the Java util function from the Java standard library. And to make that clear, I will just name this Pulsar consumer like that. And we need a message listener. It's also a concept from Pulsar. And this is Lambda. And inside of this message listener, we basically define the logic, the business logic that we want to execute whenever some change happens on the database, in this case on our book table. So I'm gonna just consume the data of this message, which is a byte array, and turn this into a string. And I just know that Debezium will provide us with some JSON data. And then I want to just print out this JSON data so we can see what's inside. And once we are done with it, we acknowledge that we consumed this one. And in this case, I have to use try and catch, because in the Lambda, you cannot add it to any method signature. So if something goes wrong, we want to let Pulsar know, and we do not acknowledge, we do a negative acknowledge, and just tell it, okay, something went wrong. And the last part is we actually have, of course, to start it somehow, and I will just create a Pulsar consumer builder where we provide the topic name and the message listener. Alright, so we have the class, and so we have the method with the correct return value and input names. Very nice. And again, creating the client is very similar to using the Pulsar admin builder. And a client can either be a producer or a consumer, as you can see here. And in this case, we want to read from the topic, so we use a consumer. And this is the topic that we want to use, and this is the logic we want to execute. It's in this message listener. We give it a name that can really be whatever you like. And in the end, don't forget to subscribe, otherwise nothing would happen. Again, I add the exception to the method signature, and please don't do that at home. Last thing is we close the consumer when we stop the application. So this is all the code that we need. And let's see if everything works together nicely. So I'm gonna bring up the Docker Compose file, which will start the database and the Pulsar cluster. Postgres is pretty fast to start when it's empty. Pulsar takes a little bit longer. And this is the line that I'm looking out for, alive true. So I know, okay, it started successfully. So now I'm gonna start the Quarkus application. And this will instruct Pulsar to download the Debezium nar file. And as soon as that is done, it will directly start Debezium and read from the booking table. So I expect that it shows up 2 entries here because we already have 2 entries in the database. And you see, there it is. So this was pretty fast. You see also here Postgres posted some details that Debezium detected for logical decoding and so on. And to show you that this really is constantly listening now, I will bring up another terminal, and we will do a little update directly on the database. Because for me, this is the beauty of Debezium. No matter how you change the data on the database, if you go through the application or if you directly query your database, it will always catch when you write something in the database, or always when you delete something, whatever you do. So here I will just insert a new book into the database. And what I expect that very soon after I do that, it will not be instant, but very quick. Here a new entry shows up. So let's see. And there it is. So you see, it's pretty fast. And just a little reminder how our table looks like. These 2 entries are created by Quarkus application. This one I just created with the insert. And we will find all this data in here. So let's bring up a Scratch file and see how it looks like. So you can configure Debezium and your Postgres database in a way that you see the state that an entry has before. But when you create a new entry, it will always be null because the before state is there is nothing. Then you have the actual content of this database row, where you can see this exactly matches the columns that we have in the table down here. So ID, ISBN, and so on. Then you have a bunch of meta information, like on what schema you're operating, on which table, and so on. And interesting is also this line, where Debezium shows you what kind of operation happened here. So OPC means that this was a create operation. There could also be a D for delete, or there could be an R for read. So when we look again at the 2 entries that were read at the beginning by Debezium, you will see here the operation is just reading. Okay, so that's it for this part. In the next one, we will update the change listener so that it actually writes our entities into Postgres, and there we can implement a proper full text search. So thank you for watching and see you in the next episode.